Thank you all for being here. Moving mountains. DevOps Days Tel Aviv. I've never spoken here before, so thank you for sticking around to listen to what I might have to say. So, it's a privilege to be here. Before I dive in, I want to ask a couple of questions to kind of try and level set, make sure we're all on somewhat of the same page. There we go. Some of you might remember this image. It's the Windows XP background launched in 2001, re-rendered in 4K. It's beautiful. And now we go back. All right. By a raise of hands, and I can see all the way to the back. Oh, okay, here we go. We're just auto. Oh, it's queuing. I'm going to stop clicking and wait. No, it's on autoplay. Nope, it's going way fast. Stop it. All right, nobody click anything. If somebody out there has a Flipper Zero and is controlling this, you know who you are, and I'll find you later. Ah, that's that guy right there. Nope, it's still happening. Okay, this is going to be fun. All right. This is just a trick to see if you're paying attention and can kind of reconstruct the order. Autoplay. Anyone? Anyone? Looks like I see a mouse moving. I don't know. You can't see it. So they're doing something. Well, I'll just kind of keep going, and we'll try and figure this out. That's great too. By show of hands, how many of you have ever walked into an environment where you are the first developer, architect, engineer, operator, and there's no system there, and you get to kind of build everything yourself? I see a smattering of hands. That's great. You are all exceedingly lucky and privileged to kind of build on a green field. We need a restart. These slides are way deep. So you get to build a greenfield environment where you have the creative possibilities to explore what you want to build. You don't have this kind of weight or baggage of systems that are kind of holding you back. I'm gonna try and click back a few. Can we get back to one? All right. All right, who's in control? I'm in control now? All right, cool. All right. Fingers crossed. Okay. So you get to express creativity without baggage holding you down. You get to kind of walk through, explore, learn new things, and kind of embed your imprint of ideas on this new environment. You get to learn along the way, you get to make your own mistakes, and that's great. We make mistakes and we learn. That's kind of how we all work, right? I was speaking to somebody recently, and they were like, what you do is magic in this operator world, in this development world. And the answer is no, we've sold you that it's magic. We fail all the time until we succeed. And they took a moment and said, well, that makes sense. I do that too. And I'm like, yeah, we just don't talk about that a lot because we want you to pay us a lot of money. But how many of you have walked into an environment where it's already built and it's a mess and it's kind of burning down and you have to kind of make it better? So many more hands have risen at this point. This is often called a brownfield environment. That comes from some industrial development where some places like in the United States might call it gray field. If it's like retail environment and you have to kind of build around existing infrastructure. This particular is a photo of Matzada, which is beautiful, which is, again, it's something that exists there. You can't just knock it down and build up on top of it. You have to respect what's there, and that is often in our systems world called legacy. Legacy is often used as a bad word, but legacy is what is left behind. It's the thing that's already there. And as a system administrator, pretty much most of my career, sysadmin, we can still use that term, right? We came in and kind of start to mop up the messes and deal with the systems and kind of make things better so that way we can continue to move forward. So dealing with legacy, I'm not even 5 minutes in. I haven't introduced myself. Eliana did. It's great. I'm already arguing about what color. Is it green or is it brown? We love to bike shed. So let me kind of make sure that you know who I am. I'm Mike Fiedler. I work for the Python Software Foundation on pypi.org. That's the place you pip install from. And if you use Python, you've probably used it. If you don't use Python directly, you probably use it indirectly. I'm an AWS hero. I'm a volunteer roller derby referee. And you can kind of hit my website there, and there's a lot of links there. And I will post links that I refer to after this talk at that website, and I'll share that QR code at the end. I've been working in software and system administration for about 30 years across a variety of different small, medium, and enterprise businesses. And for the last couple years, I've worked at a nonprofit as a security engineer. It's a mouthful. It's a lot of work. But today, I'd like to share a story of how we took a successful effort to migrate one of my mid-sized startup systems over the course of 2 years. We took 6 systems down to 1, which is not a trivial task, and I'll share some learnings and how we did that. So I had just transitioned in from a senior management position to a chief architect role. If you've never kind of gone back and forth between management and individual contributor, I highly recommend it. It gives you a deep appreciation for the other side of the house. You learn a bunch of different things. It's a related but different career. Try it out, see if you like it. If you don't, sometimes you can go back. I've done this multiple times throughout my career. It's great. You really learn a much wider view of the systems and the meta systems of your business. But lots of leaders will come into a fresh environment and kind of start to imprint their ideas and their ethos immediately, as this is a tongue-in-cheek by David. You can go visit his website. He talks about this. It's very silly. But the part that I want to stress before I go any part further, I'm going to share a lot of history, and it's going to sound like people made mistakes and made bad decisions. And what's very important is throughout this process, every single person who came to work tried to do their best. They made whatever decisions they made with the context that they had at the time, and they were trying to do the right thing. So please don't judge them harshly from history's perspective, because I don't. So walking down this kind of path, I want to give you a little bit of a system architecture of what we were dealing with. The company had started as a bootstrapped, VC-funded idea and had kind of bought some off-the-shelf enterprise resource planning software, big chunky thing, probably not applicable for a startup, but that's what they chose. That's what they knew how to use. And as they grew over the course of the next year or two, they realized the ERP couldn't provide them a fancy website that they wanted to do, so they built a website on top of it with Magento, I believe. And that was great because then they could customize the brand, the feel that they wanted to do, and still have the operations and the accounting and all of the hard parts done by the ERP in the back end. We fast forward a little bit and kind of feel that the ERP is a little bit inflexible, it costs a lot of money, it's not adequate. So we relaunched the entire company with a brand new website and a brand new homegrown ERP. This time, instead of PHP and some off-the-shelf SaaS, it's a JavaScript website and a Python backend. Using JSON APIs, this is not any like groundbreaking ideas today, but about 10 years ago, it was fresh and an idea forward of you're using Python in production. How dare you? You can't run a business on that. And we did. In the homegrown ERP, the team had already experienced kind of the need that they had from the existing ERP, and they built in functionality like product listings, sales transactions, accounting, supply chain concerns, as well as customer experience management. They built everything in-house. Today, that's unheard of. You would buy everything off the shelf, integrate everything until you explode. But back then, they believed that this is the right path for that company. Great way to kind of control your own destiny. So it started out with the earliest tables in the database. We start out with products and variants. Variants are those variations of a product, what color, what size. So when you're listing what t-shirt size and what color, and you can get the variations, get the pricing, and have all these variants associated to products. After a while, we realized that the table structure isn't exactly correct, so what do? You rename the schema and you create a new one, right? So we have deprecated product, and we have a new schema called product catalog. And product catalog is where we have a lot of other tables that express the new table structure and design that will support the company's needs going forward. We fast forward a little bit further and say, okay, well, now that we have products, deprecated products, product catalog, we need to merge these historical concerns with the new concerns. So we build a data warehouse. So that way you can extract, transform, and load all of your data from your historical orders into your data warehouse. So that way, as we change forward, we can continue to manage and say, what did this product cost? How did it do as we moved in time? We had a nightly ETL job because we were United States-based retail hours. It wasn't a fully online system. We did have e-commerce, but we needed the bulk of our transactions to happen at night, so that way they'd be ready for the retail opening in the morning. We've now moved the website out because we're going to focus on the back end here, the ERP. An effort kicked off to migrate the existing catalog to its own set of tables to its own service, right? This is the dawn of microservices. Let's kind of encompass all of that concern into a service, front it. However, one of the challenges here is that we didn't move the data, we just moved the API and used these complicated SQL functions to make the data in the same tables in the database exposed as these new APIs, and the ETL still wasn't fetching from the same data point. So we're getting into some complex flows here in order to support more flexibility on the ERP than to actually solve the problem of having one single source of truth. We were still tied to the old tables. After realizing that the new catalog schema wasn't the right structure, another team set out to re-implement it using the Data Model Resource Book. This is a book that was originally published in 1997, revised in 2001. There are now 3 volumes of it. It gives you a wide variety of common, boring, don't invent your own data models structure. You can find this on Wiley's website. If you're into data modeling or data warehousing, a lot of these are really boring and dry, but if you do this, you likely never have to do or think about it again because it's built in with extensibility in mind after years of research. Probably. So we launched more schemas called DMRB product and DMRB product views, which are materialized views in SQL to kind of, again, represent the existing data structures to the endpoint APIs. Now we have too many. We had so many schemas because sadly, each time the engineering team launched into doing this effort, they weren't able to cut off the old system. I'm sure everyone has been in a project that you launch and you get something into production and then your funding or your kind of priority shifts and you don't get to go back and kind of clean up what you've done. So you end up carrying these anchors around with you. There was even a legacy catalog too, which is always a good indicator of something that went well. And all of these had different kinds of interactions with the ETL, and that was another part of the puzzle. I want to, again, everyone did what they thought was right here, and the leadership at the time didn't understand the complexities of the technical challenges in order to greenlight further investment on these. So the first kind of key impact that I want to share is that you have to surface the business impact of what these changes are causing. The only thing that got leadership to pay attention that something is wrong here is when they understood that in order to launch a new product, instead of taking what they believe should take 30 minutes to an hour, it was taking 6 weeks of lead time of one team submitting new products, another team making sure that the ETL makes it all the way through, correcting any data mismatches, and kind of trying to shepherd this new thing into existence. And we were launching new products every 4 weeks with a lead time of 6 weeks. Once we kind of boiled it down to leadership of, well, this is costing us launch time. We can't launch unless we have a way to launch quickly. They started to listen. And they were like, okay, yeah, we hear you now. What are you going to do about it? So they've been made aware. We had the business impact very clearly. We had the business team championing that. So they said, okay, what are you going to do about it? I refer you back to the DMRB book. Instead of us trying to get our new models correct, we then contracted out a team that is an expert in an open source platform called OFBiz, which is an open source Apache project, which basically implements all those models for you. We didn't have to do it. You don't have to do it either. You could pick it up. It's ugly Java on top of SQL, but it worked. And that was the key. It worked so we could move forward. We also then learned that the team that managed the products preferred to use spreadsheets than web interfaces. So we built them an interface to upload spreadsheets, parse them out, and then put them into the data API. All right, all of that's great, but now we've added another system to our stack. So we're here, we've got some stuff, we are able to add new products, but we still haven't cut down on the errors and problems in there. So as the architect of the team, I then formed a Tiger team. A Tiger team is kind of like a tactical team. We go in, we have a purpose. And all of this is kind of a cross-functional team. We drew from engineers and said, okay, we're going to go about this and dig in and figure out how to solve this problem. The team composition of who joined and who left changed over the course of 2 years, but we marketed it as a learning opportunity. We had the people, we had some principles, and those were, we set ourselves that we are going to own whatever we do. We're going to commit to completion. So anything we do, it's going to finish. We will finish it. Every change needs to start and finish. We needed to understand the impact of what we were doing, and then we needed to leave it better than we found it. We had to clean up the messes that we found along the way. So what did we do then? We made it sexy. We talked about it in very positive terms because this is not very exciting work to a lot of people. It's very boring. It's tedious. So we talked about how to make it kind of like, okay, this is a leadership-driven project. We have the C-level support here. We had our project manager help us craft messaging, graphics. We got mugs, and we would have celebrations over every incremental win, which then it's, okay, how do we actually do that? So I figured, okay, let's go back and figure out how do we carve out all of these different things. And believe me, I'm not a scientist. I figured let's go and ask people who know what they're talking about. The blog post from Martin Fowler, he's chief scientist of ThoughtWorks, talks about the strangler fig pattern, where vines of a strangler fig kind of wrap and eat a tree, a dead tree, until it's dead, and then the tree is dead, but the vines are there. So he used that as an analogy to replace existing systems by wrapping them. And it's a great blog post. He wrote it in 2004 and then revised it in 2024 because he wanted to kind of update it for the language. And we adopted this style. We had a bunch of things running in our favor. We already had a full CI/CD pipeline where we could ship any change into production in under half an hour. We had a homegrown feature flagging system. Today I would probably buy something off the shelf, but we had one already, so I wasn't going to change it. We had good observability tooling built into our platform at the time. We were using Datadog, so we had a lot of stats-D and tracing, hey. And we were able to leverage those things to accelerate our success. We even had specific code samples that other engineers had left us because they were good utilities. So we had this is some Python code of a deprecated wrapper function. So using this deprecated wrapper, if you're not familiar with Python, you can slap this on top of any function, and this code will run as part of your other function code. So it's kind of a function calling function. And we would emit a deprecation warning, basically saying this bit of code should go away. It'll spit it out to our logging. We have this message called to a deprecated function. We would add the modules, quality name, and then a custom function around logging with a traceback, so we could see 10 levels deep who along the path had called this particular function. Because we could see, okay, this function was called, and you could try and trace it through the code, but we had so many things that were calling the same functions for the same products. How do we dig through all of that mess? So using this idea, I have a dummy module here. So if I have some function, it's going to sleep for 4 seconds. Please don't put sleeps in production code. This is just an example. And then, when you would hit this with the deprecated decorator above the sum function, we would get some notes in our log. Today, I would probably use struct log or something that structures our logs. We home grew this thing. And it would give us the module, it'd give us the name, and then all of that stack trace of where it came from. So now we have this kind of pile of logs that tell us where things are, and we have to prioritize. There are hundreds of thousands of calls to these. So we introduced GraphViz, and if you're unfamiliar, it's a really simplistic but very complex graph language, which you can programmatically generate by building blocks of, okay, here's where all these logs came from. Here's the function names and build a graph of what are the dependencies between these. A lot of dependency graph generators may use something more modern like Mermaid. Mermaid didn't exist back then. So GraphViz was there. We wrote some custom scripts to export Datadog logs, build a graph tree that looks a little bit like this. We would then color the nodes and the leaves to kind of find groupings and consolidation points, and then tag them with a Jira ticket ID and say, okay, we're going after this branch of code that if we knock off the notify abandoned carts tasks, all of those leaves will fall off. And then if we knock off the deliver app push notification tasks, all those will knock off. And then the calls to this product catalog will not be a problem. So by going methodically through, we're just going to trace everything and then prioritize based on call volume, complexity, where the consolidation and choke points are. We didn't have to go function by function by function. We could kind of cut off big swaths of calls in one shot. And then in our Datadog logs, we had the ability to observe a particular function, look for the function name, see the calls go up as more things are happening, and then once the code is gone, we had all that in our favor, right? So that's some stuff we had. The things we needed, we didn't know how the database schema was being used because we didn't have those tools yet, so we had to invent them. We didn't have an experimentation tool that we could use for our purposes here. The company already had experimentations for the front end to do kind of UI A/B testing, but we didn't have something for our back-end calls. So we had to invent some of it. OpenTelemetry didn't exist yet. This is very early Datadog APM tracing. So we had to kind of come up with some new stuff. For the schema, we were using Postgres. Postgres has a built-in cumulative statistics system. Postgres keeps track of what it does internally, and it follows every single table, index, IO hit. These are really good tools to kind of familiarize yourself if you're doing database performance. And what we would effectively do is take a look at the user table statistics and see are the calls going up or stopping. And then you could reset the statistics. Some people don't like doing that. It's fine. Or you can use a Datadog Postgres integration that would then chart those out for you, which is what we ended up doing. But having that built-in tooling to a provider we already had helped us navigate, okay, we can now drop this table, drop this schema, because it's proven that it's no longer being used, which goes back to our principle of we have to leave it better than we found it, and we must not cause negative impact. When it comes to the experimentation side, we had learned about something in 2016. GitHub had launched a Ruby library called Scientist. Scientist it performs a branch by abstraction pattern, another technique that Martin Fowler talks about, how to add an abstraction layer between what your caller and your target. And you should read more by Fowler. He's really smart. The branch by abstraction is, and this is a Ruby example, is this function says pullable by user. It will execute both branches of the legacy code and the new code, it will only ever return the result of the legacy, the current behavior. Other terms for this are control and candidate. So it would only return the control of the experiment and then compare the results of the control and the candidate. The danger here is if you're doing mutation operations, such as updates, you don't want to do this on systems that have those properties because now you're writing to two places. You want to do this with reads. Since this was products and we were getting products, that helped us a lot. We didn't have to worry as much about the mutation pattern. The ideas here are pretty straightforward. You don't have to use a library for this, but there's a library in almost every language, and we picked the Python one. That's what we were using. And they launched this pattern, and everyone adopted it because it's useful. Conceptually, you could read the blog and implement it yourself probably in a couple of hours. But you can also just use one off the shelf. So we used the laboratory library in Python. They called it an experiment, and as I mentioned, we had a JavaScript experiment package, so we called it a probe because we figured, okay, we're probing the system. We want to insert something very low effort. We added our enable probing as a Boolean flag. That was controlled by our feature flagging system because, as I said, you're executing both branches of logic, and some folks were worried if I'm executing both branches in serial, won't that add my latency? The answer is yes, it will. However, our newer system was so much faster that I believed it was an acceptable hit of adding another 100 milliseconds to a latency that's already 4 seconds long. So it was minimal, but in order to allow the ability to toggle it on and off, we added our feature flagging. The publish mechanism is basically if the results don't match. Log a warning, and then emit some metrics, and then for every candidate in that stack, also emit some metrics. This helped us compare the results and get into an evaluation of are we doing better than the control, are we doing worse than the control, as well as the results.match. So what does that look like in material? So this was our original module of our deprecated function that we now have identified we want to kill off. So we would write our new refactored function. This is a wonderful function. It does not sleep. The previous one does, so it's going to be a lot faster. And then we branch by abstraction in the caller. So we've added this probe. We set up the control. We set up the candidate. And then we conduct the response. We only return the control because that's what the probe does. And then if we found a mismatch, we would get that result in our logging, and it would tell us, okay, these were the mismatches. It wouldn't tell us what the mismatch was. It would just say, okay, we tried to do the thing, it didn't work. But over here, you can see the value is a different value, right? I have two different string values, so I'm going to get the different value. It's a mismatch. And it would emit our metrics timings, and we can see it went from 4 seconds to almost nothing because, again, I'm printing a string. That's just an example, but it's demonstrative of how it worked. And then removing the probe was pretty much yank out the old code and keep the caller function there. And by using this pattern repeatedly, again and again, we saw the latencies just drop to the bottom of everything. Now, I mentioned that there were some data mismatches, right? Because I changed the string. Ideally, you don't want mismatches to your callers because then you're not returning the same thing. In this case, I was not returning the same thing. But if I was, then I'd need to kind of figure that I wouldn't have a problem. Because I had a data mismatch, let's dig into what the log warning did. In log warning, we had a very large warning, but the part I want to focus on is this diff part. We constructed a deep diff using another open source library that will basically walk through a dictionary or a JSON-like object and show you the differences in the values and tell you what has changed where. Because a lot of data structures, they don't necessarily make sense if you compare them from an old system to a new system. We needed to figure out what those mismatches were. We had to figure out what the desired result was. We found out that we'd been serving some incorrect data for a long time and that the new data was actually the correct one. So in those cases, we had a human on the engineering side work with the merchandising team and say, hey, What's the tiebreaker here? Which one do you actually want? Very good tool. And then we used that, we actually annotated which one, so that way when you would see a mismatch, you knew which one in Datadog to look at. And then using this technique, we could identify the data mismatches, have the ETL process get updated with these abilities. A tricky part was if we fixed the data problem, we would now include more mismatches because now the thing is right and the old thing is wrong. So we had another ability that we added later to exclude known mismatches. And that helped remove some of the layers of the complexity. So again, this is scientific method. You have a characterization of the process. You have a hypothesis. You say, I'm going to experiment that this new system is going to match the old one. We predict that the information is going to be correct, and then we run an experiment. And then that's science. And then we could see that everything just plummeted. The calls to the old systems dropped. We were able to drop those schemas and celebrate those wins. Just to kind of recap what we talked about. So surface business impact. Some teams in your company have more influence than other teams. If you don't express the needs of the team to the right people and what the impact that has, it's not always going to go the way you expect it to. I had one engineer once ask me, why is the product backlog always beating out the engineering backlog? And I answered him, why are there two backlogs? Why are we not expressing the engineering concerns into the product backlog? If product doesn't care about what engineering cares about, then it'll never become a priority. So learn to speak product language and tell them, we've had X amount of outages this month because of this problem. Those outages cost us some number of dollars of cost. That we are lost revenue. If that is more than they care about doing the next project, then maybe they'll take this advice and say it's worth working on this project. The project outlasted 3 leadership changes over the course of 2 years. It was able to persist despite so many challenges to say, hey, why don't you stop now? Everything's kind of smooth. And my position was always, if we don't get from those 6 systems down to 1, we will have failed the business, because we will continue to carry around dead weight that we have recognized. This is debt. We are paying for this now. Let's finish paying for it now and never pay for that debt again. We need to kind of make sure that whatever work you are doing isn't tedious. Some of the engineers who joined this team said that this was the best rotation work. Some of them stayed on it for only 3 to 4 months. Some of them stayed on it for a year. They learned so much about the rest of the code base. They interacted with engineers from different teams, and they looked to this opportunity as a successful learning opportunity, growth opportunity, and the practices that they learned in this Tiger team, they took back to their own engineering teams and upskilled everyone else. So look to these opportunities to say, we can do big, hard projects. It takes a lot of time. It takes some investment, but it's absolutely worth it. And then do more science. So again, I want to hammer this home. Tech debt is business impact. What is boring and is toil is learning. And you can brute force at it, or you can do science. And then you can have nicer things and move really big, hard projects over the course of time, methodically, safely, and get to the end point successfully. You can find me online or in New York City. There's that QR code, and I'll have those links of all the things I talked about up in a few minutes once GitHub Actions completes. Thank you.